Alright, this is a review problem for the Chapter 6 test, benchmark 7. The intensity L of x of light, x feet beneath the surface of the water in a lake, satisfies the differential equation dl over dx equals negative kl, where k is a constant. You know that diving 9 feet cuts the light intensity in half. How far will you dive before the light intensity is 30% of its original intensity? So, you've got the surface of the water here. You've got the sun up here. You've got light shining down into the water. And we know that when it's 9 feet deep, the light intensity is cut in half. So let's call the amount of light right when it hits the water L sub 0. Okay, and of course, depending on how clear the water is or how dark the water is, the light might go through that water better or worse, depending on how much dirt is in the water and that type of thing. But we know that when you get down 9 feet, when you're 9 feet below the surface, that you're down to half as much light. So you're down to half of what your original light was. When you see a differential equation like this, where it's saying the differential or the derivative equals some constant times the amount of light, what equation do you think we should use here?
Y equals y sub 0 e to the kt.
Right, y equals y sub 0 times e to the kt. Instead of y, what variable should we use? L. So L equals L sub 0 times e to the k. Instead of t, though, what variables being used up here? Well, L is in place of y. X. Instead of t, we're using x. So L equals light intensity. L is the light intensity. X equal the distance below surface of water. Distance below the surface. Okay. So let's start off. We know that when you go down 9 feet, you're going to have half as much light intensity. So let's plug in 9 for x. What would we plug in for L? Half of
L sub 0.
L sub 0. Half the original light intensity. What would I do next? Divide by L sub 0 on both sides. That would leave you with 1/2 equals e to the, let's call it e to the 9k. Natural log both sides. Natural log of 1/2 equals natural log of e to the 9k. Move your 9k out in front of the natural log, because that's a logarithm rule. Let's bring it up here where we can see it better. Natural log of 1/2 equals 9k times the natural log of e. What's the natural log of e equal again?
1.
That's equal to 1. So it's really 9k times 1, which would just be 9k. Divide by 9 or multiply by 1/9 on both sides, and we're going to get this. 1/9 of the natural log of 1/2 is our k value. So we found k. That was our first step. Any questions about that part of it? So we know our constant. That constant probably depends on the water. If the water is clear, it might be a different constant. If the water was dirtier, it would be a different constant. So depends on the water. Here's the question though. How far will you dive before the light intensity is 30% of its original intensity? So now we're going to go back and use this formula again. Now we want to know how many feet. So we want to find x if only 30% of the light is getting through. 30% of the original light intensity. First of all, do you think it's going to be more than 9 feet or less than 9 feet?
More.
It's going to be more than 9 feet because as you go down, you're going to have less light is going to filter through, right? So if at 9 feet, where half the light intensity was there, you'd have to go deeper before you'd only have 30% of the light. So what will I put in for the place of L right here?
0.3 L sub 0.
0.3, right. 30% of the original light, that's 0.3 L sub 0, equals L sub 0 times e to the, now for k, put in your 1/9 times the natural log of 1/2 x. We're trying to find x. divide by L sub 0 on both sides. That would leave you with 0.3 equals e to the 1/9 times natural log of a half x. What's the next step?
Natural log.
Natural log both sides. Natural log of 0.3 equals the natural log of e to the 1/9 natural log of a half x. Move that whole exponent out in front of the logarithm, because that's a logarithm rule. You get natural log of 0.3 equals 1/9 times natural log of a half x times the natural log of e. But we know the natural log of e is equal to 1, so let's be timesing by 1, we can drop that off. Any questions so far? Everybody good there? What's the next step? Divide by this number here? Yep. So you're going to have to take natural log of 0.3 divided by that entire number, 1/9 times the natural log of 1/2.
Could you have the natural log of a half over 9 and then just multiply by reciprocal?
Yeah, maybe that's it, yeah. We could do that. You could either do it this way, or you could say, you could, instead of multiplying by 1/9, it's the same as dividing by 9. So then we could multiply by the reciprocal of this fraction on both sides. Let's do that. So you have 9 over the natural log of a half times the natural log of 0.3 equals x. So if you type that in, slide this over a little bit. Type it on your calculator. 9 divided by natural log of half, I'm just going to use 0.5, is that, times natural log of 0.3, 15.633. So x equals 15.633. What would be the label on that? Feet. Yep. So you have to be between 15 and 16 feet below the surface of the water before you'd be down to only 30% of the light intensity remaining. Any questions about that? Probably